Thomas Fehlhaber. And Thomas Fehlhaber is since 2003 the managing director of Unipor, of the Unipor Ziegegruppe, which is a company but also an association of small and medium-sized businesses of the brick industry. He did his PhD in structural engineering. He was lecturing at the TU-Darmstadt, and in 1995 he was working for 8 years in the concrete industry. He will not talk about concrete. We have another change in material. He will talk about 3D printing bricks as a complementation technology to 2D extrusion. Thank you very much for coming.
Yeah. Thank you for the invitation. Ladies and gentlemen, a warm welcome. And I was asked to talk about the 3D printed bricks at this symposium as we started a project just 2 years ago. And we were interested how 3D printing could work with coarse ceramics. But first of all, I would like to say that I'm not telling a secret when I'm not a specialist in 3D printing, and I'm not bringing along 3D printed buildings or elements made from clay. However, I like to tell you a bit why we do it, and you need to understand actually a bit of our history. More or less, we are thousands of years old. Bricks were used 5,000 years ago in Mohenjo-Daro, and they built a city made from bricks, more or less similar from the procedure of the manufacturing as today. The only bit which is missing actually is the firing of the bricks. So it is clay, water, and forming. They didn't have an extrusion process like today. The city was, or let's say that is the rest, or the bit of the UNESCO city, Mohenjo-Daro in Pakistan, which we can see today and visit. The walls are similar to those we know in our surrounding, in our environment. And when we have a look to the stations in between the past and today, there are a lot of different types of architecture actually, but today bricks are used in 3 types of masonry actually. The so-called monolithic wall, the so-called cavity wall or insulated wall. And that's a business we actually do today. We are producing in Germany roughly 6 million cubic meters of clay bricks, which are used for 50% of the buildings in Germany. So it's a relatively huge business, and you may ask why I talk about 3D printing and why we would like to change or complement a business which is running perfectly at the moment, because building business is good in Germany since, let's say, 2011. But where we came from is that we needed to install every year new products, and since the 90s we use a mortar joint, a thin mortar joint actually, which is important for the thermal insulation. In the past it was a mortar joint 1 centimeter thick, and this is a heat bridge actually in a wall. So two things we needed to develop. We needed to develop for a monolithic wall thermal insulation as well as the mortar joints. And then from 1970, actually, which is the oil crisis coming along, and this is the age where we were founded. All the family-run businesses we have today argued about the development, and they said, hang on, we can't do it ourselves. We need to put together all the businesses who have the same interests, and we want to have monolithic walls. In the 90s, we started with the energy efficiency regulations in Germany called NF and Wärmeschutzverordnung. And today, we are close to nearly zero energy buildings. So we actually can make it. We can build passive houses with our bricks. So we actually are an insulation material which can cope loads as well. Thus, the development of thermal conductivity was really a hard way to do. We had lambdas of 0.18 early in the 90s, and today we stick with 0.08 with bricks which are traditionally manufactured. In the next step, we were pushed and needed to improve further, and that was done in the whole industry in Germany by filling the holes with mineral fibers, with perlite, with polystyrene, phenolic rigid foam, or mineral wool flocks in our case, which we developed ourselves in order to have a competency where we were successful in the past in having 25% of the market share. And today, or in 2010, we could work with bricks for multi-story buildings with a lambda 007. And in the next step, we were able to have a mortar system which is a mortar plate which can be laid on the bricks and just watered afterwards. So no mixing is any longer needed. The mortar pad system is, or mortar pad system is just to wet the bricks, to lay the plates and cut them if necessary, and watering them and fix the brick. So today we are nearly zero energy building ready. So the insulation history is done, in my opinion. There might be that there is a small step in the future, but at all it is done. So the next question is, what is the future actually? And how fit the 3D printing into that business? If you look to the trends in our economies in Europe, there are a lot of topics are quite important to the people. Environment, resources, health, safety, regionalism, all such things. And if we look to the past, I would suppose that all of our new products were efficiency-driven. Efficiency-driven in a type of manner that we all the time wanted to be better with regards to the building energy we use during the lifetime of the building, rather than using or looking to the production energy of all the bricks which we use for the building, for example, or the production energy which is in the building itself. So we are in a circular economy. We're recycling concrete, we recycle glass, we recycle steel and all the stuff. And we are able to recycle bricks as well. But in the future, we are asked to be climate neutral, which means in total, we don't use energy for heating and so on, which is coal-based. So it needs to be a renewable energy which is be used. And also for the manufacturing of the bricks, we should be climate neutral at the end. A small step which we did actually is to fill in a material which is wood-based, which brings us a bonus in the energy we use for the production, but is not the end of the game. The wood in the brick is replacing mineral fibers, so it is more energy efficient. It's a hybrid product. But when you think about our production, then we have a clay pit, and we have the soaking bins, which are necessary to have a continuous material property at the end. And we pile up all the clay for 1 year in the yards, actually. Then we give it to the bins, and afterwards the production starts. So clay is not easy to handle. And now we want to print with a nozzle clay. And we thought 3 years ago that would be an easy thing to do, because we have the experience in extruding clay. Extruding clay in our business means that there is clay being extruded 13 meters a minute. So it's a lot, it's a high speed. And the whole production process, including grinding, firing, and filling, is oriented to the extrusion process. So the 13 meters need, or the volume which we cope with per minute, is in line at every time in this process. And we are thinking about the future, how to protect the climate, what is global warming potential of the bricks itself, and the firing is necessary in order to have the strength and the durability of the brick. So firing cannot be, we can't think about of taking away the firing from the process itself. If you think about global warming potential and you want to know how much CO2 equivalents are actually in the atmosphere for a square meter of wall, then it is for our products roughly, let's say, 35 to 40 kilograms per square meter. But today we use the recycled bricks just for substrates. So this is not a circular economy we like to have in the future, where we like to use or reuse building elements or elements of the wall again. Architects in Germany, the association BDA, the architects like to reuse the materials rather than to recycle them and have new materials. They want to have the elements back. And if we do so, then we would need to think about interlock systems, because we should remove the joint. The mortar joint is something which we cannot have in a circular economy, which is more than just the raw materials to be reused when we like to reuse bits and pieces of the building itself. And therefore, the 3D printing came in because we are able to rethink our geometry and can think about interlock systems, fixing of the bricks together, and afterwards we had also the idea if we could have facade elements which are curved, which are interesting for, or where architects are interested in new designs, because today masonry, brick buildings, they are, let's say, cubes. There is no curved wall, actually. It's a lot of work on site if you like to have a curved masonry wall. And because we are industry, the first thing we bought was a roboter. That's the easy thing in this bit. But if you think about the clay sleeves, they are 2 microns thick, for example, and they are electrically charged. And if you like to push clay through a pipe of 2 millimeters or 3 millimeters through a hose like that, the friction is high, and you like to have higher pressure, to push more material, and that might be a problem if those sleeves, the clay sleeves, have more friction together, are pressed together. On the other hand, you need additives, which we never used before in our extrusion process. So after 2 years, we found one mix of clay, which came not out of our pit, which was actually the goal, to have a procedure for the clay which we have in our own pit to extrude or to print. However, it's quite important to make such an experience, because on one hand, you have this 3D printing experience and the way you like to design 3-dimensional geometries and have new designs. But on the other hand, you learn a lot about your material, which you never thought, which gets important for you. Because in the old-fashioned way, where you extrude a coarse clay material, you never are confronted with such issues, problems. And if I think about the future development of the simple bricks in our business, what do we need to do after having 2 decades of developing insulated bricks? We like to have bricks with more strength. So we need to go back into the material again. So 3D printing is something where we learn from our material for the common business, and we can have new materials, clay materials for sure, which we are going to print 3-dimensional. And we wanted to print a facade which you can see bits and pieces of it at the exhibition stand. We wanted to show such a facade at the BAU 2019, but we couldn't do because we were not able to print at that speed that we are ready to the exhibition. But I'm pretty sure that we would be able today, so next time is 2021. And we have to take the challenges. New clay mixes, use of additives, so which additives? We need to understand the chemistry as well as the amount which we need to put into the clay mix. Optimize the grain size, which means grading curves. We need to investigate into the grading curves, drying and firing of products. There might be opportunities to reduce the temperature in the firing from 800 to 500, more or less, with other additives, which is done at the moment in other research programs. We need to understand the opportunities of new designs, solve the dimensioning and capacity issues, because it's nice to print in 3 dimensions, but if you are in a building, then you need to have rules in order to design the capacity. Explore fire resistance and durability issues as well. So it's a lot to do in the future, and if I compare it to the concrete bit or the steel bridge, we are, something like kidding in the backyard at the moment, but I guess we can make it. And I have to thank a couple of people, Professor Ulrich Knag from Darmstadt, as well as his co-workers and the project partners and sponsors as well. And I hope to see you at the exhibition stand F68 in Hall 11.1. Thank you.
Thank you very much. I kind of disagree that you're behind concrete, because you delivered tons of reasons of why we should do all these things, and I think that was an interesting and important message that you gave. And I think it was interesting that we now understood that you deal with different problems. You have an established industrial production facility, and then everybody would say printing bricks, replacing that would be completely stupid. So this is really about integrating something new into something established, something efficient. And in that sense, there are completely different challenges than printing a single object, I think. Are there questions?
One.
There's a microphone coming.
Thank you for your great presentation. I enjoyed that. As you told us, we use brick for centuries. And do you think now it's the time for changing the core material, changing the clay? Because clay, like concrete and steel, is very heavy, and transportation also is use the energy, as you told us, and create a CO2 emission also. Do you work in other material that's today, because of the 3D printing, also is available, like biomaterial? Thank you.
When you have the clay in the pit, actually, you have something like a density of 1.4 to 1.5 in Germany. It's depending on geology and such things. And in the past, we needed to light our clay all the time for the insulation issue. So we came down to something like, let's say, 800 kilograms. We made experiments with 300 kilograms as well. It's a corrosion process. We put something in it which is going away in the firing process. The important thing with it is to have a polarization process which is homogeneous, actually, so that all the pores are small and designed. Today we put polystyrene in it, we put wood in it and all the stuff which we are not controlling really. If we would control the pororization process, we could go down to 300 and 400 kilograms with all the strength we have today. But then, and you need to think about today, a kilogram of clay brick is 20 cents. And if you like to do all this stuff, you can get up easily to 50 cents. And we need to understand what the people like to pay for. And you need to afford for it. Thank you.
I understand this, what I call a rather one-dimensional optimization process towards energy-saving aspects. But if you look into history, a wall is also usually to fix things on it, and it's a very difficult project to fix something to these highly optimized thermal systems. Maybe we would have a possibility with the 3D printing if we know where we want to fix something in the future, but sometimes we don't know. So, and this causes additional cost,
Yeah.
I mean, you can see all the different devices you can get now just to fix a window into these walls. So what could be the solution in the future? Is this...
The fact is that in our project, which is now 2 years old and is coming to an end, in the next weeks until Christmas, I hope, we are able to print that brick which we have actually proposed to do, which is a brick for the window frame to fix the windows to the frame and have a geometry which is better to fix it all to it. Yeah? That's something which we can implement in our product range and which we could sell in future very quickly. However, we want to make more than just a couple of bricks to fix a window or something like that. But this is something where we thought at the beginning this is quite easy to do. Yeah. Okay. Thank you.